we go. So the 5 basic graphs we need to make sure that we know in order to get this whole thing rolling, right? 5 basic graphs. And if you'll notice my cute little icon here, I kind of see this like the home device on your iPhone, iPad, little Nook, Kindle, whatever. When you push that button and it brings you right back to the home screen, this is what I'm talking about. 5 basic graphs. Here we go. First one that you need to make sure you know, y equals x. Y equals x is a straight line, positive slope, really is just the most basic of lines, okay? And believe it or not, where we're headed with this is when I put something like y equals x plus 3, what we're going to eventually look at is that this is really just a shift in the graph. That it literally is just picking it up and moving it up or down. Okay, and that's where we're headed. If I gave you this equation, y equals x squared, hopefully we know what that one looks like. What's that graph look like? A parabola. Way to go, Casey Fuller. The next equation that we need to make sure we know is the log graphs. This includes not just log base 2 or base 10, but also your natural logs, any log base, whatever. And of course that graph, whoop, crossing at 1. Now, if I'm talking about logs, hopefully it makes sense that then I would talk about what's the other basic graph we would need. Exponentials, e to the x, 2 to the x, 3 to the x, any of those exponentials where they start very close to 0, they cross at 1, and then they skyrocket, right? They just climb incredibly fast. And then the last graph, or the last kind, I would link to be almost a group of graphs, meaning your trig functions. So you have your basic sine curve and cosine curve. So those are your 5 basic graphs. We now have circles. And even though that's not part of our basic graphs, understanding that x squared plus y squared equaling our radius squared is a circle. And if you look at your homework packets right at number 1, you're going to notice the first 4 questions have to do with parts of a circle. If you remember from back in chapter 6 when we were doing systems, there were a couple of questions that we asked about y equals, and it would have the square root. Do you remember that? I know it's been like 3 weeks, but that's what they are. And they all look like this, where they're in the form of a square root. We can easily see the first 2 from chapter 6. Those are the ones we did, where we solve for y, and we recognize that anytime we take the square root, it's plus or minus. And they specifically talk about a certain part of the circle. In other words, this circle, x squared plus y squared equals 9, right, is a circle with a radius of how much? 3. And so what these are doing is they're pointing out a certain part of the circle. For example, this first one says y equals, and it says positive square root. Where are the y's positive? Is this the top? Is it the bottom? Is it the right? Or is it the left? It is the top. So we literally just draw the top part of the circle, put your intercepts down, and it's done. So the one in your homework obviously is talking about, I think it's x squared plus y squared equals 25, right? And so you're dealing with a certain part of the circle with a radius of how much in your homework? 5. Way to go, Casey Fuller. All right, this next one. I am. All right, so this next one says y equals negative square root of 9 minus x squared. Where does that go? It is the bottom. And so again, you just label the intercepts. It's implying I want where the y's are negative, just by the way it's written. Now, even though we didn't do these in chapter 9, maybe you can use your own common sense to think, okay, we're looking at x equals, and it's saying positive. So do I want the top, the bottom, the right, or the left? We want the right, because we want where the x's are positive, and the x's are positive on the right. Does that make sense? Now the next one, what do you think that one is? Top, bottom, left, right? It is on the left. And so hopefully on your homework package, this becomes quite obvious as to what number 1 looks like. Instead of having 3's, we would have 5's. Does this make sense? Great. Now before we get too far in this, it really is important that you know what y equals x squared, x equals y squared, or even the negatives look like. Because what we're about to do is then look at these in, well, as you can tell from number 3 in your homework packet, in different pieces. Because much like the circle, in the parabola, sometimes they just want to focus on just a part of the parabola. And they'll specify it just as you see in number 3. So before I do number 3, which I will in just a moment, I just want to reiterate, you have y equals x squared. We already talked about that with your basic graphs, right? If I ask for negative x squared, how would that look instead? Sad face, lovely. X equals y squared, and I don't know if anybody got confused by this, but when you have x equals y squared, many of you thought, okay, it tips on its side, but which side does it go towards? It goes to the right. The way that we can tell is because it's positive. If I had the negative y squared, then we would open towards the negative x's, or on that side, which I believe was the other part of number 2 that you had to do. So you would have this side. So there is a way that we can break down each of these equations, though, and indicate I want a certain form of that equation, certain part of that graph. And so to start, let's look at this one. If I solved this equation here for x, then I would do x equals the square root of y. Are you with me? And as always, whenever you take the square root, there's always the plus or the minus. So I would have x equals the square root of y as one of them. And let's just look at that. This means the x's are a positive. I want, look at this graph right here. Where are the x's positive? Is that the right or the left? It's the right. So this graph is looking for that section of the equation. We'll get there. Next equation. X equals negative square root y. This is where the x's are negative. Do you follow that? X equals negative. So I want where the x's are negative. And so that indicates that I want the left side. Now this young lad in blue here asked a great question. What happens if there's a negative underneath the square root? If there is, x equals the square root of negative y, then really, if I took a moment, and I don't want to take too long with this, but just don't write this down yourself, just watch. If I square both sides, you can see that what we have is x squared equals negative y. We solve. Do you see that the negative underneath is basically saying I'm using this graph instead? Okay? So when, back to this. What this is saying is x equals positive square root, but the y's are negative. X's are positive, so that means to the right. Y's are negative, so it's this part of the graph. Right, like you actually have Bell's palsy, and it's just one side of your face is drooped. That's rough. That was really rough. Lyme's disease is nothing to joke about, all right? Okay, next one. X equals, poor people watching this video would be so insulted. I know. The negative on the outside of the square root. Remember, anytime you take the square root, there's still plus or minus. So we're going to look at both versions of that. This is saying your x's are negative and your y's are negative. So x's are negative, y's are negative. Doesn't make sense that it's in that quadrant, the third quadrant. Follow that? All right, so x equals y squared. Similar to the one before, we're going to look at the different variations that this could have. Again, solving for y, you would have y equals the square root of x. Because this says y equals, that means we're looking at where is y positive and x being positive. And so y is positive, x is positive. It wants this first quadrant form of the graph. Now, just in contrast to the one that we've already done, what I want you to notice is these both were in the first quadrant. One is y equals and the other is x equals. Do you follow the difference? And so to know the root of where it came from, it helps to know, does it open up or does it open on its side? If you're ever confused, remember you can always square both sides and see where it came from. So this would be y equals x squared. Okay, those open upward. If you squared both sides here, you'd have x equals y squared. Oh, those open on its side, if that helps, okay? All right, next one, y equals, of course, the negative square root x. And so this would be the negative portion of that. Your x's are positive, your y's are negative. Then you have, of course, y equals the square root of now having that negative underneath the square root, similar to what we did before. Now, this is saying your y's are positive, but your x's are negative. Y is positive, x is negative. So it wants that quadrant piece, the one that's in the second quadrant. And then lastly, we have where they are both negative. And of course, that falls in the third quadrant. In your homework packets, as you look at them, number 3 in particular, I only give you 3 of them. And you'll notice the reason I start the whole unit with these very things is because throughout this entire packet, you're going to see these. Some people in this room will memorize them. They'll memorize all 8 versions. They won't ever really figure out the relationship. They'll just memorize. Some of you are good at that. And great, but that's short-lived. Because once you take the test, you'll pretty much forget it. If you figure out the relationship, the fact that, okay, what's the root graph, and then what those signs mean, x is positive, y is positive, or x is positive, y is negative, and so on, it helps you be able to link that more long-term for yourself. So that's the idea of what we're doing in here. It's not just to memorize 8 other graphs. I want you to actually learn the root graphs and then what those signs mean. All right, the only last thing I would say about your homework packets is number 4. Number 4, if you'll notice, are 2 lines. And it does springboard us into what we're talking about tomorrow, what happens when you switch the x and the y around. We've already talked about it in this class when we dealt with inverses. We're going to deal with it more in depth tomorrow. Any questions?